Hi to all. So in this video, I'm going to walk you through a very quick example of how to calculate the delta, right? So we know that delta or the hedge ratio is that value that allows us to build this riskless portfolio. And the riskless portfolio is just the basis of the risk neutral valuation that we use in options, right? But long story short, let's just go to the point and let's solve the hedge ratio for a call option and for a put option so you can sort of have an idea about how to do this. So if we are looking at a call option, right, we have two possible scenarios. We have the stock price today. In this case, as we are seeing, the stock price today, we are assuming we have two scenarios. Scenario one, which is the good state of the world, is that the stock goes up, moves up to 152. And the other scenario, of course, in this binomial model, so in this basic binomial model, we only have two possibilities. Either there are good news or there are bad news. And the bad state of the world is that the stock goes down to 120. So once again, let's just think about some the possibility of some let's think of earnings announcement, for example. A company may announce earnings that exceed the market expectations, and in that case, well, we expect a good state of the world and stock will go up. But if, on the other hand, that the company does not meet the expectations of the market, then we're realizing that the market will just penalize that stock and the stock price will go down. But going back to the call options, in this particular case, we already know that we can calculate the intrinsic value of our call if the stock price moves up, and that we can do it by simply using our formula, which is max of the stock price, right? Stock price in this scenario that it goes up, so it's 152 minus the strike price. So in this example, we are given some information and the strike price is 127. So then that we choose the max of the difference between the stock price and the strike price, or zero. And there we go. So we know basically that if the stock goes up, moves up, our call option will have an intrinsic value of $25. But what happens if the stock moves down? If the stock moves down, then we will have an intrinsic value of stock price minus strike price, or zero. And we can clearly see that 120 stock price minus 120, right? Minus 127, which is the strike price, that would be a negative number. So then that's why our formula of the call option is max of stock price minus strike, or zero. So in this case, our max function will end up choosing the zero. So if, long story short, if the stock price moves down, we end up with a call option having an intrinsic value of zero. Now, what is that delta, the hedge ratio, right? The delta is basically that value, or the number of shares, or how many shares we have to buy in this we're long, or in this riskless portfolio that is comprised by, and I'm going to change a little bit our screen here. And it's basically, if some of you have seen this in your book, so we have stock price up, call up, then it's going to be equal to stock price down minus call down. And delta is that value that makes this possible. So in other words, if the stock price moves up, or if the stock price moves down, the portfolio will have exactly the same value. Let's assume that is $2, right? And but there is more to that then only being that value that achieves that helps us achieve this risk neutral portfolio, and it is that delta is basically how exactly call moves for each dollar or for each when the stock price increase, how is the call option increasing? And so this is what we have seen in the past as rise over run, or basically the slope. So we can remember this formula as call up minus call down divided by stock up minus stock down. That is the uh, formula that we can use. And now we can go back to our Excel. So our formula for hedge ratio is going to be call up minus call down divided by stock up minus stock down. Okay, so keep in mind that formula. You can look it up in Canvas, and then let's just use it. So call up, we choose the value that we just calculated, and keep the parentheses here, right? So call up minus call down, and then divided by stock up. And let's use the parentheses again here, stock up minus stock down. And then basically, I'm realizing now, right, that we should have just place the call up here, then the call down here, according to this small table that we're completing. And now we can use the formula. So that's call up minus call down divided by stock up minus stock down. Once we have that, we have our delta. That delta is once again the slope, or that's the derivative of the call option price with respect to the stock price, or in other words, in simple words, that's how much the stock price changes with each change in the stock price. Okay, so we have just calculated the hedge ratio or the delta, and we can if we want to do the same for a put option, we can do this, and it's just as simple. So step one, we just calculate the value, the intrinsic value of the put option. So let's assume this case. So in this case, stock price is 126. If stock price goes up, it goes up to 196. If it goes down, it goes down to 73. So the put option price, if the stock goes up, and keep in mind, if the stock moves up, then the put is not doing well, right? You do well in a put option if the stock price moves down. So when you use the formula of the intrinsic value, which is going to be strike minus stock price, or zero, um, max, and I'm forgetting the max here. So we're going to get a zero as intrinsic value in this case. Now, if the stock price moves down, we are doing well, and our put option is doing well because we our put option gains value when the stock price goes down. So then we use the formula again of the intrinsic value of the put option, and it is just once again strike minus stock price, or zero, the max of those two. And now we have some intrinsic value which is 55. Now to get the hedge ratio, let's just copy the values here. If the stock price goes up, the put option takes a value of zero. If the stock price moves down, then the put option takes a value of 55. And our hedge ratio is basically the put option if the stock price goes up minus the put option if the stock price moves down divided by the stock option, by the stock if it goes up, minus the price of the stock if the stock goes down. And there we go. Do not be surprised that the hedge ratio in this case is negative. That simply means you're taking a short position when you're building that riskless portfolio, and that is going to be in most cases, that is going to be the case if you're dealing with put options. Okay, so we have just completed the hedge ratio, calculating the hedge ratio for both a call option and a put option. I hope this is helpful, And if you have any questions, feel free to send me a message. I'll be glad to help. Take care.